So we're going to go on to the word problems, and we're going to do these 3 word problems together. Hey, so a lot of what you're going to see when we talk about word problems are geometric applications. So in the first case, it says the length of a rectangle exceeds its width by 4 inches. So the first thing you should do is probably draw a rectangle. And if the width is x, what is the length? Well, it exceeds it by 4 inches, so it's x plus 4. Find the dimensions of the rectangle if its area is 96 square inches. So if I were to write this as area equals base times height, 96 as my area equals x times x plus 4. Now when we solve by factoring, we need to do 2 things. We need to get it in standard form, and we need to make sure it's set equal to 0. So distribute your x, subtract 96 from both sides, and here is our new equation. So solving, what multiplies to be negative 96, but adds to be 4, give you a second to think about it, 12 and negative 8. So x plus 12 times x minus 8 equals 0. 0 product property, x minus 12, plus 12 equals 0, or x minus 8 equals 0. So x could be negative 12, or x could be 8. Now, can x be negative 12? Can I have a width of a rectangle be a negative number? No. So I know that this has to be 8. So if this is 8, what is the length? 12, because 8 plus 4 is 12. So x equals 8. X plus 4 would have to be 12. So my dimensions are, it's an 8 by 12 rectangle. Okay, let's talk about another popular geometric application when we're talking about solving by factoring. It says if the measure of one side of a square is increased by 2. So the side of the square is x. If I increase it by 2, I'd have x plus 2. And the adjacent side is decreased by 2. So the other side is decreased by 2. Now it has an area of 32. Okay. So can I solve this? If we want to find the side of the original square, can I solve it as it is? Maybe, if you can think about what those numbers would mean. But first we got to get it into standard form. So first outside, inside, last, or this is the product of a sum and difference. So we get x squared minus 4 equals 32. Got to set it equal to 0, so subtract 32 from both sides. X squared minus 36 equals 0. Hey look, a perfect square. A perfect square. A difference. So we have a difference of squares. So x plus 6 times x minus 6 equals 0. 0 product property. X plus 6 equals 0, or x minus 6 equals 0. So x equals negative 6, or x equals 6. Now again, in regards to can you have a negative side length of a square, the answer is no. So the original square is 6 centimeters. So we're talking about 6 centimeters. There is another way to solve this, and that kind of deals with what we're going to be doing later in the week. Is if we had x squared minus 36 equals 0, We can add 36 to both sides, we get x squared equals 36. Take the square root, x either is positive or negative 6. But it's not negative because of the context. Okay, the last problem that we're going to do together is a projectile motion problem. And this is our projectile motion formula. And in this formula, the height of the object is given as negative 16 t squared plus vt plus s, where t is the time in seconds, v is the initial velocity, it can either be upward or downward, and s is the initial height. And so sometimes you'll see that as h sub 0. So we're using s right here. And this is for projectile motion problems that you're going to be seeing a lot of. So Brad tossed a baseball in the air from a height of 6 feet. So this is my initial height, with an initial upward velocity of 14 feet per second. So this is my initial velocity. Enrique caught the ball on its way down at a point 4 feet above the ground. Okay, so 4 is my height here, because that's at the end of the problem. How long was the ball in the air before Enrique caught it? Use the model of vertical motion in that case. So remember, it's in standard form almost, but we need to set it equal to 0, so we subtract 4 from both sides. We get 0 equals, okay, now we have a negative leading coefficient. I don't like dealing with that, so I can divide everything by -1 to make my numbers just a little more friendly, if possible. And then what else do we see? We have a GCF of 2. Okay, so what multiplies to be -8, because A times C is -8, and adds to be -7? -8 and +1, right? So that's how we're going to break up our B term. Okay, and you can solve by grouping. So the 2 is still there. Out of my first group comes an 8t, so left behind t minus 1. And we have t minus 1 right here, so the only thing I can take out of that is the greatest common factor of 1. So 2 times 8t plus 1 times t minus 1 equals 0. If 8t plus 1 is equal to 0, then t equals -1/8. If t minus 1 is equal to 0, then t equals 1. Now t stands for time. Can we do -1/8 second? No. It's t equals 1 second. So we can say, hey, this situation doesn't work for us. T equals 1 second. We've got 13 different problems, and you have answer choices at the back and on the bottom. Remember that in a lot of word problems, negative solutions don't make sense for the context. You can't have a ladder that's negative 10 feet tall or something like that. So remember to use the context. You may not have 2 solutions that work. And in some cases, when you ask for dimensions, we've given them separately.